especially someone is working as business BA. I think I forgot the name. Someone in the same, group, same batch. He or she was working in BA role. So he or she might have a bit knowledge on top of business intelligence. What is business intelligence and how that plays the role in data engineering and all. This bar is not shifting. Why? Yes. So business intelligence or BI, how it works. Let me show you a diagram. So BI application is business intelligence applications. It's been used for every sector of businesses and all nowadays. So how that thing is working? Suppose I'm implementing the BI application on top of particular maybe a shopping mall or yeah, maybe shopping mall. In a shopping mall there is various shopping outlets. So each of the outlets we are collecting the sales related information. Those are our input data. Okay, we are collecting all the information into BI application, and by the BI application we are creating lots of charts and graphs, so that why we are doing this thing. BI application, it will be collecting the source related information. Suppose uh, while purchasing something in a shopping mall, uh, they are collecting our data, they are collecting our feedbacks as well. Okay, what is our experiences? That is not just for showcasing the thing. They are using all the data, they are collecting all the information from each of the users, they are aggregating those things. Why they are aggregating those things? This is their business strategy. Maybe they have lots of goals. Okay, suppose they are checking what are the best thing they are uh, suppose in a feedback you are putting a survey over there, that which kind of clothes or which kind of particular things you are coming for that particular shopping mall. So they will be emphasize that particular product to be produced more in the factory. Okay, so this kind of thing. So they are trying to checking what are the feedbacks, what are the particular attraction from a particular point of perspective of a particular users. They're also tracking the salaries of particular employees working in that particular shopping mall. They're checking what are who are the sales representative is more focused on their jobs. They're trying to uh, trying to convince their customers to purchase a particular product. They're collecting all the information. Okay, they're publishing some rank. Who is the top sales? I mean, mm, a sales representative who is managed to sell more things, and what is his strategy? Then he can train the other one, or just like this, he is getting much more incentives, and it will be showing to everyone so that everyone can focus on their jobs and they can also receive the incentives. This kind of stuff. They have lots of mottos actually. The business application is being established. The main motto should be enlarging their business to grow their business. Okay, so whatever sales data we are capturing, maybe some billing related information. So, but in a particular transaction, what particular item a particular employee, a particular customer has purchased, what number of, it's the quantity is only one or more than one quantity, what is the discount, everything is also been captured in the transaction. There is no issue. As well as the feedback form they need to fill up, it's also they're checking how to increase their business. If there is any low feedback, they will be trying to emphasize that feedback to be in, that particular field of area to be increased. They'll be helping to understand the business owners how that can be improved and all. So when our BI application is ready, we can able to answer the end user. End user means who is owning the business. The entire BI application stuffs will be done by data engineers. They will be collecting the data, they will be processing the data, and they will represent the data in meaningful way in charts and graphs, then business owner can check the data and they can identify those kind of questions. Sales in the previous quarter, revenue growth in past 5 years, best selling product for each season. So maybe this is also scenario in a particular branch. Okay, suppose I have in my shopping mall, it is having 15 outlets in various region of the same country. Okay, so a particular product is best selling for a particular branch. Okay, and another product, it is the worst selling. Even we can see the product is very less number of sale for a particular branch. If we are collecting data and we are analyzing the data, we can see the least selling product, it's been purchased in another branch with a bit bigger number. Okay, then as per the business owner, I'll be stop showcasing my list selling product into that particular shopping mall. I'll be reducing my productivity of that product because I'm producing on that one, but it is not getting sold in the particular shopping outlet. So why I'll be producing these things? And rather, whatever extra things are there in that particular outlet, that thing I can transfer to that particular outlet where it's being sold. Okay, so this kind of easy business strategy, we can check it inside the data and we can take necessary steps so that our business criteria is fulfilled. Okay, so this is the main thing. Is it understandable for everyone what I'm trying to say? If there is any stuck point from anyone, please ask me questions, because this is especially the overall things. The business intelligence is the overall things why we are required in this area. So when we are presenting the final data, on top of that, we are creating charts and graphs, that is fine. Even the data scientist or data scientists, they are creating the logics. Suppose I have checked this thing. I have worked with a data scientist in a particular pharmaceutical project. In a pharmaceutical project, there is a lots of patients available. So we have patient tables and all the criteria related to patient. Now, data scientists, they have prepared a particular, complex logics and all, and they're predicting that the patient should be leaving that particular medications for that company. Okay, the chances of getting, he will be removed from, not sure removed. He or she will be leaving that medications for that particular pharmaceutical company was 93%. So a prediction has been made, and after the next days, it was really happened. That particular customer or that particular patient just left the medication for that company, and he or she joined in another companies for medication for some reason. So that is the thing. Before leaving the particular company, we need to check. If I'm working in the company's business, I need to check what are the probable scenario he or she can be get back to this medication again. Okay, maybe he or she not likes the behavior of some employee. Maybe the product cost is high. This kind of scenario can be there. Maybe he or she found some other product which is a bit cheap in my competitor product. Maybe this is the scenario. We need to analyze this. What is the reason? Based on that, we need to take the strategy, and the strategy should be fulfilled again. So this is the entire thing. OLTP system means the source system where we are receiving the data, or where the business intelligence are receiving the data. Okay, this is source data, the transactional data. Okay, so suppose we are the customers we are purchasing some products. So whatever data I'll be providing to their machine. So that is OLTP data, online transaction data. Okay. So OLTP data, it's not a meaningful data, whatever we are getting from the source side. There is ETL tool. ETL tool will load the data from source system to the target system. It's DW means data warehouse. Okay. ETLs are jobs. ETL means extract, transform, load. Those are called jobs. So daily basis, we are loading the data from source system. We are cleansing the data. We are transforming the data so that while storing the data in data warehouse, the data should be meaningful in nature. Okay. On top of data warehouse, we are creating reporting. The particular machine learning owner or the data scientist, they can do their own way of logic implementation on top of data warehouse to predict some particular business criteria that I told you. After that, it was been provided to the decision owner or the business owner to take decisions. What should be their plan? What things needs to be updated at the source side, or what new business strategy should be updated. Suppose for the patient who is going to leave the company, who is going to leave the medication of that company, we can give him or her a more offer. Okay, if the customer is reliable and he is there for long years, maybe 15 years, why we should be losing that customer? We are having lots of revenue from that particular patient. So why we should be leaving those patients? So that's why when we are going to get this kind of prediction, we can have a bit more offer to them so that he or she can stays back, or we can remove what are the issues they are facing. Maybe if it is a cost issue, then might not be the same scenario. It's totally dependent on the business decision, but they need to take initiatives so that their revenue should be earned much more. So that's why. So the strategy planning maker will change the thing again to the source system, and we will be receiving the new required data. What should be the fruitful in nature in the very next day. Okay. So this is called BI cycle. It's a closed loop. We are receiving the source data daily basis. So suppose today new data is being loaded at the source system. It's loading through by ETL into data warehouse, and by reporting tool that needs to be presented in form of charts and graphs to the decision owner. Decision owner are taking decision or taking new strategy and pushing it to again in the source planning system. This is called BI cycle. Okay. Now the thing is why we are incorporating these things in data intelligence, data engineering part. So this is the overall thing actually we require. The data engineers can work in OLTP systems data. The data engineers can work in the ETL systems to load the data from source to target. Data engineers can work in data warehouse, maybe for data analytics part. Data scientists can work on top of data warehouse, maybe building those logics of predictions. Data engineers can work on top of this reporting tool, okay, to present the data warehouse data into meaningful charts and graphs. Okay, so those are various aspects of various roles the data engineers can take. After that, it will be handed over to the business owner, the one who have completed MBAs and they're owning the product. So product owner, or they're in higher position, or they're in the management position of that particular company. Okay, then it will be their responsibility. They will be taking care of, and the changes should be happened over here. Then again, it's work for data engineers. So we already learned SQL. SQL will be used in each of the aspect. We are pulling the data from this system and pushing it to over here. While working in ETL, SQL can be used. So I need to take data. I need to take few columns or few rows from source system. So in ETL, we have the place to put how the source thing should be pulled. So I'm just doing a select query from the source system and we are pushing the record over here. So I need to know what are the select query. It's not only a simple select query. Maybe I need to join this select query with another table for reference data. Then I'll be pulling the data. So I need to know the SQL query over here. Now when ETL is over, I'm doing some data modelings and all in data warehouse. I'm doing some data analytics part over there. So I need to know the SQL. So SQL is the basic building block for data engineers in BI cycle. Okay. So when we will be learning Python, we'll be learning because Python can be used as a ETL tool. Okay. We can load the source data to target by using Python. Okay. I'll be just going ahead those steps one by one. So why we are learning these things? This is the thing. This is the overall thing a particular product owner can see, but maybe we are working in a small thing. We are not aware what the entire picture is, but the entire picture should be this one. Okay, now what is OLTP system? I told you OLTP where we are getting source transaction data. So OLTP, the full form of OLTP is online transaction processing system. Okay, so online transaction processing systems. Okay, just this has been written. You can quickly check it. Are the class of systems that can manage, facilitate, and support operational or transaction-oriented application. Okay, just a quick example, bank transaction, anything related to banking transaction, sales transaction in a retail store, I told these things, railway booking and cancellation, etc. So all the things, we are collecting these things from the sources. Those are called transactional data. Maybe different platform is being used for railway systems, railway booking and cancellation. They are using some black screen. Particular person who is helping us to how to, put the ticketing values and all. They're using a mainframe computer, mainframe platform over there. They're pushing all the information and storing into OLTP systems. The data is getting stored in OLTP systems. Banking transaction. There are lots of debits and credits are happening in each hour per single day. So those all source related information are stored in OLTP systems. Okay. Now what is OLAP? OLAP is called online analytical processing. So whatever we are receiving from source side, that is OLTP data, that is not ready for the analytics purpose. As I told you in the previous picture, the OLTP systems, it's not the meaningful data. So we need to do lots of cleansing operation, lots of transformation operation. And finally, we need to load the data in data warehouse. So before presenting the same data into data warehouse, we need to prepare the data warehouse data so that it is good to represent in reporting layer. So while representing the same into reporting layer, we have to store the data for OLAP systems. It's called OLAP. So representing the data means it's OLAP. It's ready for analytics purpose. Okay. So online analytical processing systems, that is called OLAP. So you can see systems are the class of the systems that are used to analyze information. This typically requires large volume of data because we are collecting all the single OLTP source systems. We are cleansing the thing and we are combining all the things maybe in a single table and it's ready for analytics purpose. OLAP system relatively low volume of transactions. So OLAP systems are designed to handle the complex queries that are used to discover trends and patterns, and these queries are usually executed on a data warehouse. Okay. Moving to the next slide. So this is the final decision support system that I told you. He should be from the business side. So he will be checking those questions. What is the sales distribution region wise? So when our data is ready in data warehouse, it is ready for OLAP systems, and after that the reportings are present. Reporting means the charts and graphs on top of OLAP systems are completed. Then decision support system, they will be checking for those kind of questions. What is the sales distribution for each region? How did my revenue improve in last 5 years? So they can check this kind of things, and they can take the decision of the strategy. What should be the strategy for the next day? Okay, or the next quarter. Whatever loss I have faced, it's fine for this quarter. Let's move ahead with the new strategy in the next quarter. So this is the thing. Those are called, they are called decision support system. This is a sample thing I just want to convey to you. So this is been stored as OLAP database, a particular tabular structure I have present. And when we represent the same thing, when we convert the same thing by reporting tool, those reports can be generated. That can be some bar plot. Okay, bar plot is having, you can see different kind of bar plots are there. There are pie chart as well. So whatever things I'll be representing for the request of decision owner, that thing should be meaningful over here. I'm creating a charts and graphs, but this is not helpful to them. That should not be the scenario. We need to prepare the things such a way so that those are meaningful in nature, and it will help the business owner or the decision maker to take easy decisions on those questions. Okay. Okay. So till now, any doubt from anyone? Whatever we are learning, the overall picture of data engineers, how it's working and all. If there is any, please tell me. I mean, BI topics, the 2 days topics, it is not very technical. It's very much conceptual, we can say. So the concept needs to be cleared when you are online, live in a particular project or application. It's very much useful. They can use lots of terminology. Then you need to understand the same thing over here. Maybe here, or maybe you are learning from any other places. That is fine. But those terminology must be clear to you. Otherwise, might be they are telling something. Might be you also know the thing, what it is, but you were not able to answer it properly, or you can not able to do it properly because of that. I mean, you do not have the knowledge on those terminologies and all. Okay, that's fine. We can learn this thing really one by one. So moving to the topic, data warehouse. So I already mentioned that the data warehouse is this part. Just to mention in another flowchart how the things are working again. So it's an you can see it's an example of the entire BI system. So first data entry operators are there. They're collecting the transaction and pushing it to operational database. That is our OLTP systems. By ETL tool will load the data in a non-business hours. Okay. Suppose whatever transaction we have made today, the same day is not the same transaction record. Suppose today from day start to day end, whatever new data we have received at the night time, or you can say at the non-business hours time, the new records are being pushed to data warehouse by ETL tool. Okay. At the night time, because that time nobody will be checking if there is any issue with the data warehouse, nobody can check. Suppose while job loading stuff, there is something happens with this data warehouse. but it should be done in non-business hours so that cannot be affected data warehouse data. And when our data warehouse data is ready for the very next day's morning time, the reports and charts on top of data warehouse can be built over here, and that can be produced in front of my business owner. That should be next day's morning. So they should be having the concept, whatever new records we are receiving today, that will be reflects to the charts and graphs at the very next day. This should be the scenario. Even there are lots of critical BI applications as well. They need the data immediately. Okay, so there is lots of live reporting stuffs as well. So it's very, sync up with the source system. Whatever data I'm receiving, immediately it's been captured at the reporting systems to take the decisions. Some critical applications is also having this kind of concepts. Okay, based on how the data is critical, what systems we are working. So this is the thing, the data is getting loaded. Okay, now the data warehouse data, those are subject oriented. Data warehouse means it should be a database. Suppose we have worked in MySQL. In a particular data warehouse, there are lots of tables should be available. On top of this tables, lots of views can be available. So in data warehouse should be subject oriented. Maybe I'm working in a business, in a particular business, a particular subject oriented data can be stored in a single data warehouse. The data should be integrated in nature. Okay. Data should be time variant. So we can get the data, the previous historical data as well. Okay. Because we need the history. Something happens maybe last 10 years, how they recovered the data and what was the slope of growth. Okay. So if we have these scenarios handy, then we'll try to overcome the same kind of scenarios in my current situation. Data is non-volatile in nature. Non-volatile means it will not be off and on. So data should be always presented there, available there. So those are the important concept we need to mind for the data warehouse. Okay, this is another, and I put an architecture over here. So those are the various source systems, OLTP systems. The data is coming from maybe Excel file, maybe different databases, maybe some mainframe systems, some external source systems are there. So we are extracting the information by ETL tool. It's a bit detailing manner. The flowchart has been drawn. So the data is collecting by ETL tool and pushing it to staging area. Okay, we are not directly storing by the ETL tool in data warehouse. There are lots of steps there in between source system and data warehouse. So first of all, the first step should be all the different source systems data should be coming into a single stage area. Okay, we are not doing any cleansing or transformation operation over here. It's just one-to-one data load from here to here. Okay. So when this load is completed, we are loading the data into data warehouse. But we are doing some cleansing, transformation operation, cleansing operation, as well as some aggregation, summarization. Aggregation means the thing we have already discussed. Suppose, it's a miniature form of aggregation we have already covered. Just like in SQL query, we have covered group by stuffs over there. We have done lots of summation, average, mean, mean. Those things we have covered. So those are called aggregation. That is been stored it over here in data warehouse. Sometimes we also use data marts to store the data. Data marts are nothing but is a miniature form of data warehouse. We are splitting the data warehouse, and it's a subset of data warehouse. We are keeping small databases to split it out and saving it over here. Now there is another thing called ODS. It's called operational data store. There is also some feature on top of that. Suppose I told you that we just need a real-time data. We do not need the delay. Suppose we received the data source data today and we are delaying to pushing the same thing in data warehouse after 1 day. So we just need the thing to be synced up quickly and we are seeing the live data. Whatever I'm receiving in the source system, within some instance that should be presented in ODS. So for the real-time data, we need to use ODS systems. Okay, that's the concept I would try to say over here. Here it's a quick thing. ODS means an operational data store is a data store used to analyze near real-time data. Real-time means as when the things are happening to solve the day-to-day activities. So especially if the project is very critical, if the data is very critical in nature, we need to solve it immediately. Then we need to use ODS. And I told about data marts. What are those things? Data marts is a miniature of data warehouse that supports the requirement for particular department or business process explained in the below. So just like a data warehouse contains data from multiple subject areas, means multiple departments in a particular organization. A data mart is a simple form of data warehouse. A simple form of data warehouse, we are splitting the data warehouse data and pushing it to, and when it's a single subject area, we are just pushing that subject area to a single data mart. Suppose for this kind of transactions, sales data I'm pushing into one data mart. Finance related data I'm pushing into another data mart. Marketing related information I'm pushing into another data mart. Okay. But when collecting the information, we are storing all the things in a single data warehouse first. Again, I'm representing things in a chart for insurance data. Suppose I am working in an insurance company. So how the insurance architecture should be looking like? Business intelligence architecture, it should be looking like in this manner. So insurance OLTP data warehouse databases, it's OLTP systems. Sorry. So from OLTP systems, we are receiving various kind of data, property related insurance data, automobile related insurance data, commercial insurance data. So each of the data, we are pushing it to each data mart. As I told, data mart should be single subject area. I'm skipping the data warehousing part over here. But there should be stage layer. There should be everything. Just I'm trying to do a source to target mapping. So each subject area's data should be pushing each of the data mart. And then it's a OLAP systems now. On top of that, I'm creating charts and graphs. Okay, so each of the property department's head will be checking the data. If there is any combination of maybe property and automobile, or maybe automobile and commercial, then we need to merge the data into another data mart and show or build the reports on both of the data. So based on the entire requirement, we can merge the data as well. Okay. So this is the entire picture I want to show you once more time, skipping the middle part over here. It's just one-to-one mapping. We must be do these things by ETL tool. There must be some stage area, that is fine. But this is the overall picture for insurance. Okay, now just I want to mention two things before I go to the next topic. While storing the data in data warehouse, suppose we have created the ETL tool, everything is fine. We are storing the data in the data warehouse or data marts with form of some tables. Okay. So while pushing the data in tables over here, that should be, we need to follow some rules. Okay. So what are those rules? We cannot easily store the data. Just like I need this data, I'm storing it to another table. This is not the concept. We need to maintain two kind of tables there. One table is called fact table, and another kind of table is called dimension table. We need to store all the data in either fact tables, and another approach is dimension table. In the fact table, fact related information should be stored. In the dimension table, dimension related information should be stored. Now I'll be telling you what is fact and what is dimension. This is the entire thing what I'm storing the data in the databases of data warehouse. Suppose in data warehouse, I'm using MySQL database, whatever we have covered in last sessions. So there we are creating lots of tables, but we are not following whether it's a dimension table, whether this is fact table. So just for basic learning purpose of SQL, we are creating the tables in our own way. We are creating the column names. But when it coming to the picture of the data warehousing stuffs, we need to follow particular rules. We need to check how the business strategy can be built. So we need to create the reports over there. So we cannot easily create the reports. To create that particular reports, we need particular columns name over there in our data mart table. So then we need to determine whether the data mart table should be a fact and dimension. If it is a fact, what particular column should be stored over there? If it is a dimension, what kind of data should be stored over there? So now we'll be coming to this topic. What is fact table? What is dimension table? And what are the different types of data they can be stored? Okay. So it's time for fact. So when we'll be receiving the data, if we just try to question on top of data, how much, how many, those questions, if we just ask on top of fact data, on top of data, whatever I'll be getting my answers, that should be your fact. Okay, suppose I'm receiving, we are receiving some data from shopping mall. So how much quantity the particular customers bought in a single billing on that particular day. So that is always a fact. So how much, how many, what is the total transaction for that particular branch in a day? Total transaction, how many transaction, how much transaction? This is a fact. So it's generally fact answers or fact should be numerical in nature generally, but dimension should be also numericals. But we need to understand the business first and we can determine. But generally, fact should be numerical in nature where we can put the aggregation. We can do summation on top of that. We can do mean value over there. We can do standard deviation on top of there. We can do variance over there. We can determine what should be the max, what should be the mean. So those are called fact. Okay. So fact is also can be called as measures. Some of the system you can see they're telling fact as measures. And those are different facts available. Means revenue can be a fact, cost can be a fact, number of accounts can be a fact. All those things you can see it's measurable by numerics. Okay. Now, if we store all this information in a particular table, that is called the fact table. Here I have represented two fact tables. One is called sales table, another one is billing table. In the sales tables, you can see what are the facts over here. Sales is a fact. Floating data type is there. So this is a table. Inside the table, those can be the column name. Different column names are there. So sales is a column having float as data type. Quantity sold is a column, integer in data type. Price is a column, float in data type. Discount is a column, it's float in data type. So in the fact table, all the fact related information are highlighted over here. Okay. And then what are the other things? The highlighted is black. Those columns are not exactly fact. Those are different keys. Rather, we can tell these are foreign keys. So if we just quickly recall what the foreign key is, we have learned in the second day. Foreign key will be helping us to join with the primary key from another table. So that another table could be our dimension table. So in a part, I'll be coming to the next slides quickly. So there we can see lots of dimensions are available. So suppose there is a store dimension, a store table is there. In the store table, store key is the primary key there. So we need to set up the link up between the sales table and the source dimension, sales table and the source dimension, store dimension by using the store key. We have another dimension table is called product table. Suppose it's there. So to set up relationship between fact table and dimension table, we are introducing this product key. So basically just I want to convey you the fact table should be contains the fact related information as well as the all the foreign keys. You can see there is key mentioned over here, date key, store key, product key. For the billing table, date key, customer key, service line key, rate plan key, and the red color highlighted ones are fact data. So fact table not only consists of fact data, it should also contain the foreign keys. Now, what are those primary key? I mean, no, I'll be coming to the dimensions quickly. Then you can link up the things. Okay. Okay. So dimensions, if we just questions on top of dimensions, who, what, when, where, whatever answer I'll be receiving, those are called dimensions. Okay. Just a quick nature, just like I'm just populating customers table. Okay. Customer, time, geography, those are all dimensions. So this is the example of dimension, just like I told you, store table. There's all store related information. So suppose I told you I have 15 outlets over there. So in the store table, there should be 15 rows having those columns. There may be a store key, a store name, street address, city, space, region, country. You can see no numerical value is there. Only store related information is being stored. And over there, store key is a primary key for store table. If we are just creating a systems, the corresponding fact table should be having this foreign key available, store key, so that while representing the OLAP systems, we can join between this primary key with that foreign key and join between each other. The same thing happens for product as well. The product table product key is there. In the product table, product key is working as a primary key, and the same key is there as treated as a foreign key in fact table. Now, how they're joining, we call them as data modelings and all. We'll be learning the things in later days. Okay, just try to remember what's are facts, what are dimensions. In the dimensions, we should be storing this kind of information. Suppose we have the product dimension, all the product related information should be there. We are giving a primary key for the product that is called product key that should be unique for each of the product. There is also product ID. It can be also primary key, anything. This is product name. Product name cannot be unique. Product group. What is the group of product? What is the brand? What are the departments? So those are the product dimensions. And we are storing this thing in product table. So in the next day, we can see how the relation can be established between fact and dimension. Okay. So any doubt from anyone till now? Fact and dimension.
No.
Okay. So this is very much conceptual. In the very next day, we'll be covering the next chapter on top of business intelligence. When our fact and dimensions are ready, we'll be moving ahead with the data modeling part, and we can go ahead with the other stuffs. What needs to be covered, we can quickly check it over there. Okay. So if there is no doubt, we are fine to close it. Let's catch up on Monday. Happy weekend to everyone. Enjoy your weekend.
You too. Thank you.
Yeah. Thanks everyone. Bye-bye.
Bye.